Okay.
It's really however, it's just like you're talking to your peers, really. Shirtless and all.
We are recording now, so whenever you're ready.
All right, ready?
Yeah.
Okay. Brian, can you tell us about how do students learn about all of the programs that are related to engineering at DMAC?
Well, I think one of the ways that prospective students learn about the programs at DMAC is through our discovery days. Within the engineering and pre-engineering programs, the recruiters do an excellent job of trying to schedule a whole bunch of different experiential learning, usually structured in the morning or some portion of time where they'll actually rotate through a series of different programs, getting to learn a little bit and hear a little bit about each one of those different programs. And then in many cases, they've even spent the afternoons or a portion of that time taking a field trip and actually going out into industry to learn a little bit more about how that education is put into practice.
We should all be doing that.
That's my hope.
Yeah, I know.
What's it like in your program? So who are you? What programs do you work with? And what do you guys do the first semester to kind of help students figure out?
Great question. So I'm Bryan Burkhardt. I serve as chair of 3 different programs here at DMAC. I serve as chair of the Electronics Engineering Technology program. I serve as chair of the Robotics and Control Systems Engineering Technology program, as well as the newest of the 3 programs, the Renewable Energy Technician program. What's interesting is while those are 3 different credentials, and we could even tack in a diploma on top of that, the reality is all of those programs really get their same common start. And so within their first semester, students are taking foundational classes in electronics and electronics fundamentals. They get to learn about circuits and Ohm's law. They're applying math to be able to solve problems. They're also learning about digital applications and digital circuits. And from there, they then can begin to split off into these different disciplines, but that's usually after the first term.
Are there any activities that you do in that first term to help them find, like, to be excited about the different areas?
Most of the stuff that we do is incredibly boring and dry. Our students usually leave every day crying. In fact, it's kind of a measure or an assessment. But on those off days, when for whatever reason an instructor is having a bad day and things go well and students actually learn, what we usually have happen in those cases is we're trying to provide students a whole bunch of tangible and real world examples. Sometimes it's through stories, because one of the great things about DMAC in general, but certainly the faculty members within our department, is the industrial experience that they had in past lives that they bring here. That's what makes this so valuable for our students in general. But beyond the stories, it's about taking those applications and putting them into practice right here in our labs. So our students may hear about a theory or some sort of principle, and then they're actually going to test it or experience it for themselves through experimentation and through labs. And that's very common within our program, that it's a combination of lab as well as lecture.
Did you choose courses that existed that fit all 3 of your programs as those first semester, first year courses, or did you build them?
We did select things that were already in place. To some extent, these foundational classes that we have right now in that first year, or especially first term, are more industry standard based classes. We continue to evaluate the content of those classes to make sure it's relevant, but to some extent, that foundation has never changed. Some of these programs in one form or fashion, while we've changed names over time, have been around at DMAC for more than 40 years. And the foundations that were taught then, to some extent, are the same foundations that are now, because they're just as applicable in the workforce. And that is very essential. Our employers and our industrial advisory committee continues to remind us of that they need to have those foundational skills, because it makes them better problem solvers. It makes them better troubleshooters when it comes to the systems, even though those systems have continued to evolve and change over time.
How does that curriculum design help with recruitment into the programs, but then also retention and graduation?
Our students quickly learn, and even our prospective students quickly learn, that they don't have to ask the question, when am I going to use this? Because there is so much integration of indicators of when they will use it. Even in the newest and best iterations of that technology as it continues to change. We know first and foremost that when it comes to technology, things are getting smaller, things are getting faster, and in reality, that hasn't modified the way we teach. We can continue to bring in those topics and those theories into the foundational elements that our students get exposed to in their first and second terms. And so our students continue to hear about the relevance as it addresses the current business practices, the current business models. And while a lot of times they hear the kind of negative stories of this is being outsourced or this is now a disposable product, our students also understand that some of the things are not able to be discarded. They can't just be thrown in a landfill and go to the next retail store and buy another. Some of the stuff that they're working on is a one-off. There's only one in the world, and so it comes to repairing it and maintaining it. Or sometimes they're working with a client to design the only one of something in the world. And so a lot of those key core foundational elements had to be there because the problem-solving practice requires it to begin with.
Do faculty fight over students in those foundational courses, like renewable energy versus electrical engineering tech? Like, or how do you help students find out which of the three sort of options might be a best fit? Do they sort of jump back and forth? Like, what's student behavior like in terms of that?
That's a great question. The way students kind of decide their track is more based on either their own interests. In some cases, it is when an employer comes in and visits. One of the things that we didn't visit with or discuss before is we continue to try to expose our students to prospective employers throughout their entire 2 years within our programs so that they can hear about what benefits are like and what pay is like, but also what are the working conditions. And so the students kind of begin to see, I could picture myself there, or I could be doing that. And so they somewhat self-select. But other times they'll hear from their colleagues, their counterparts, and their peers, because some of these folks are already working in industry now, and so a peer will come in and say, hey, my company's looking for another person, maybe you should apply. And so they can begin to even get a sense of that and work as well as earn gainful employment while they're still taking classes. So I wouldn't say there's a lot of competitiveness for them. There's also just so much interleaving and overlap between them as we go through it. But also, to some extent, it's where their personal passion is. Renewable energy is so new for us that we don't have a lot of good direction as to how they're going to interact and interplay. The biggest thing we can say in that front is be prepared to work outside. And so for those who have an affinity to work inside in air conditioning, installing solar panels outside on a roof or in some sort of trellis is probably not suited for them.
What do you do as faculty to create the environment where peers are encouraged to interact in such a way that they're inspiring or helping each other out?
Well, I think one of the things that it naturally is formed, and cohorts are naturally formed so that they can have the students, let's back up on that. I think the structure of our program is set up so that students can have natural cohorts. They frequently will take a lecture and a lab course together, which to some extent they may be able to share their voice in answering questions as posed by an instructor, but certainly when it comes to the lab environment, they get to work with one another, shoulder to shoulder, and see how someone else performs. They can ask questions of one another, and I think that that dialogue and that learning and experiencing someone else's questioning helps them even learn. So I think that that breaks down some of the barriers of friendship that happen, at least in a collegial and professional environment. But I also think moving forward, what they begin to see is these folks want the same thing as I do, and they have the same interests I do, because that's where things begin to present themselves more and more. And we share this with our students all the time. If you're only coming to class and this is the only time you're thinking about this content and this topic, I'm not so sure that this actually is the right track or the right pathway for you. But if you're also bringing in, sharing, and conveying the experiences of dabbling, testing, or if nothing else, looking at cool YouTube videos online of someone else doing something, then all of a sudden we begin to say, this may be the place. You're in the right place, and you're in a comfortable environment where there's other folks that are geeking out the same way as you.
Love it. Great. Awesome. Anything else? Cut? Yeah, we can cut, I think.
There's like
Unless
we could
there's
use
anything else you want to share or talk about.
I really think that students need to come to our program. I'm talking to you. Can I add one more thing here? Just from the standpoint of, I know I am supposed to kind of be representing that engineering, pre-engineering, and manufacturing tracks all at the same time. The one thing I might state overall is, first and foremost, I've never had an experience where I personally thought, boy, I've had too much math and taken too many math classes in my life. And I would convey that to just about any student. I also admire the fact that DMAC has wonderful structure and scaffolds in place to be able to help folks with those things that they believe are psychological barriers to them, such as the math and the gen eds and things like that, with smaller class sizes and tutoring and things like that. We have those supports in place to be able to help students, but also math becomes different when all of a sudden you get to see it in application. Whether it's in engineering or pre-engineering, or whether it's in these manufacturing and electronics type environments, it begins to make more sense. Because no longer are you just learning how to use a new tool in your tool belt, so to speak. You get empowered to be able to pull that tool out and use it to solve a problem. And I think that's very important. The other thing I would state is, we need to make sure that we're telling a story that there are good, high-quality jobs and moreover careers in these workforce environments and in these pathways. And it isn't just that you have to go on to a 4-year engineering school. Folks make really good money. Folks get to continue to use their hands as well as their brains to be able to solve the types of problems that are here today and certainly are going to be posed tomorrow.
Awesome. Yeah, that's part of the goal, is to make sure that the website has like some of those job outcomes right there. So like as a student is clicking through, looking at options, they see, what could be not just like 4-year, not just transfer, but making sure the certificates and the diplomas and the AAS degrees, the non-credit coursework and outcomes, like career advantage. We want to make sure that if they're interested in engineering and manufacturing, that they see job opportunities, they see credit, non-credit, career advantage, they see it all in one page.
Well, and I think that seeing it all on one page is important. I think also telling that next step of, I don't care if you already have a degree in this.
Sure.
I want to be able to break down as inviting as possible the mindset of, I learned everything when I took that class before or when I pursued this engineering degree. My personal sentiment is, we need to be structuring DMAC so that folks revisit frequently. That retooling and going back to school for small doses of knowledge or large doses of knowledge and portions of knowledge is not some sort of social stigma that needs to be broken, but instead is commonplace. Because that's what's going to make us globally competitive. It also is what's going to redeem, I think, people as humanity, one, to interact with one another, to continue to fulfill those mental stimulation that we need to learn a new skill or a new trade or a new whatever, and then frankly, also be able to make them continually a healthy and viable contribution to society. And so I don't want our students even, oops, I keep touching my mic, I'm sorry. I don't want our students to think that this is a one and done. I want them to know that they're welcome here for continuing ed practices, just to get that one retooling or that reskill, or continue just because it wasn't in their program and therefore required, that they still can come back and get that, and it may make them successful in that next avenue. So I think that's a story that DMAC needs to be telling over and over and tell to the rest of the world, because too many folks say, I got my bachelor's degree. Why would I ever consider a community college for X, Y, and Z, when in fact that community college is doing some of the innovative stuff that you never would be able to get your hands on or be able to do, and yet is going to make your personal business more profitable or you more valuable within the business you're currently in.
I love that. Yeah,
I hope I gave you some sound bites. Anyway,
Funny.
and sorry for going off in a negative direction about we hope our students cry a lot. So, but I had to throw that in there. So.
Yeah.